Okay, so we're going to record a conversation in our notes for the Thermochemistry Lesson 4, Heat Capacity and Specific Heat. Hopefully you have already done the attendance, the bell ringer. Let's look at this image, this data table here. All right, so it says define specific heat. Well, that's a totally new word. So let's look at this data table and let's kind of consider what it says. First of all, what's some observations you can make? You guys online can answer in the chat. What are observations you can make? Well, number one, there's different materials. Aluminum has its own number, iron and steel, copper, brass. This tungsten has its own number. Hydrogen is 14,000, whatever specific heat we're talking about. Whatever this means, each of these materials has its own number. You might also notice steam is like water vapor, really hot water, vaporized water, but it has a different number than water. Seawater, which is salt water, has a different number because of its different composition, right? So one thing that we could observe about specific heat is that they are different for every material. Okay, so let's go ahead and write that in our notes. Let's start a note page on specific heat. So I'm going to go ahead and title my notes specific heat. Okay. And the first thing that we observed is that every material, it is specific. I don't want to use that word again in the definition, but it is different for every material. Okay. All right, let's look at those numbers a little more carefully. As we can see, the C, we use different symbols for specific heat. Some people will use C, some people will use CP, some people, like we'll see with Professor Dave, use an S. But let's look at the unit we have. So it's C is joules per kilogram Kelvin. So let's write that in our notes. The unit is a derived unit. So we'll go ahead and list that. It is joules per, so that's where we get that negative superscript up here. That means it is on the bottom of a fraction. It is per. So per kilogram Kelvin. All right, so let's digest that. Let's take that down a little bit. What does a joule measure? A joule measures energy. In this case, it'll be heat. We're going to measure the heat. We'll go heat. What does kilogram measure? Well, what does gram measure? When we're thinking about units and standard units, we know that kilogram is the standard unit of mass, okay, in the SI system. What does Kelvin measure? Temperature. So we know that sometimes for mass we might use grams. The standard unit is kilograms, but sometimes we'll use grams. In science classes, what is the other thing we sometimes use for temperature? A lot of times, probably more times than not, in science classes, you have used degrees Celsius, right? So sometimes you will see specific heat tables that give you a joules per gram degree Celsius. And sometimes, a lot of times, like in this one, you have the standard units with the kilograms and the Kelvin. So when we think of specific heat, let's define it using the unit that it has. How would you say this? If I told you read this unit, how would you say it? You would probably say joules per kilogram Kelvin. And so when you say that, you are literally saying an amount of energy per a unit of mass times the temperature. So for each, an amount of energy for each kilogram degree Kelvin. And that is the definition. So the definition of specific heat is the amount of energy. So we'll kind of put in a couple little words to make it a better sentence. But the amount of energy needed to raise, for this unit, would be 1 kilogram of a substance. So we know if we have a unit, we're measuring something. So of the substance, 1 Kelvin. So remembering that Kelvin is that temperature unit is really important. All right, so let's take a look at the other picture that's in the lesson today. Kind of move our notes away. What can we tell from this? All right, if I have glass, 1 kilogram of glass, and I raise its temperature, however that might be, by direct heat or by sunlight, whatever, I raise the temperature 1 degree Celsius, which is the same amount of temperature as 1 degree Kelvin. I'm going to need 840 joules of heat. So the specific heat of glass is 840 joules per kilogram degree Celsius or per kilogram Kelvin. I need that much heat to raise the temperature of the glass by 1 degree. All right, let's look at this example of water. If I have 1 kilogram of water and I raise its temperature by 1 degree, I need 4,200 joules of heat. Give me a thumbs up if that definition makes sense. Well, I guess I'm kind of head nodding some sort of, yeah, okay. All right, so I wanted to talk a little bit about heat capacity, and I'm going to let Professor Dave talk about calorimetry and give you that example. But let's go to our notes on full screen. And specific heat is very specific. Cheesy, right? But specific heat tells us a specific amount of energy for 1 gram of the substance for 1 degree Kelvin. You're going to hear about heat capacity also. So we're going to give a definition here. And I want you to think about how is that different. Heat capacity is how much energy is needed. So it sounds a lot the same, and it is a lot the same. It's needed for a sample to raise 1 degree Celsius. So what's the difference between specific heat and heat capacity? Ta-da! In heat capacity, we don't have a specific mass or a specific size of the sample. But with specific heat, it is a specific, this will help you remember, I hope, it's not just for cheesy value, but specific amount of energy for 1 kilogram of the substance to 1 Kelvin, to raise up 1 Kelvin. So that's just the differentiation there. I'm going to stop recording for a second, and we're going to watch the Professor Dave, and then we'll come back and do some example problems. All right, so let's go ahead and look at the equation that we have. I'm going to encourage you to go ahead and write this in your notebook. I'll show you what I write on mine, but you need to write the equation and what each of those variables mean. So go ahead and do that. Q is the heat added. So if Q is heat, we know that Q is going to be in joules. M is the mass of the sample, and that's going to be in kilograms or grams. We have to look at our problem when we're doing that. We're thinking about it. CP is the specific heat. Remember we said specific heat is different for every material? Well, that's going to be different for every material. And we know that that's going to be in joules per kilogram Kelvin or per gram Celsius. Okay. And then what does delta T mean? Delta is always change. No matter what formula you see, delta will always be change. So change in temperature. All right. So if we know what these variables are, then we can do the problems just like a regular math problem. So let's go through the examples that are in the lesson, and then I'll give you some time to do the CK12 problems, okay? So how much heat is required to raise the temperature of 50 grams of water by 10 degrees Celsius, the specific heat of water? I don't know about you guys, but sometimes when I look at math problems, I read it and sort of glaze over. So here's what you need to do every time you come to a math problem. If you know what the formula is that you're going to use, which we do because we're going to practice this one, start with that. If you don't, think about, okay, what is the question? The first question says, how much heat? I know that my Q is heat. So I'm going to go ahead and write the formula that I'm going to use. Q equals mass, specific heat, and the change in temperature. And then you might not have to do this step, but I think it makes life a lot easier if I go ahead and write my variables down so I know what I'm going to plug in and where I'm going to plug it in at. So I go back to my question. How much heat is required? I know that heat is Q because that's what I just wrote down. And so that part of the question, that's my variable I don't know. That's my unknown. How much heat is required to raise the temperature of 50 grams of water? Well, 50 grams is a mass. My CP is listed right there at the end of the question. And you guys will probably end up memorizing the specific heat of water. Okay, now I've got another variable. What do I got to do? Okay, how much heat is required to raise the temperature of 50 grams of water by 10 degrees? Well, it doesn't give me a starting temperature, and it doesn't give me any temperature. But to raise the temperature, so I'm just changing it 10 degrees Celsius. So how many times did I read that problem? Probably 6. But if you go back and read it a few times, you're going to pull out all of the information that you need. And then it's just a math problem. Then we're just going to plug in what we got. We don't know what Q is. That's the variable, the unknown we needed to find. M, we're just going to plug in my specific heat, 4.18. Now, make sure that when you write these derived units, you write them correctly so that you can cancel the units when you're ready to do that. And then your delta T is 10 degrees. So before we do any math on this, it's super convenient. We're just looking for Q. We're going to look at the units. Grams on top, grams on bottom. So they're going to cancel. Degrees Celsius on top, degrees Celsius on bottom. So they're going to cancel. So we know that the unit that we're going to have is joules. So then I can check my work there. I can say, all right, I know that Q is measured in joules. So I'm on the right track. So on this, pull out our calculator. Just going to go straight across. 50 times 4.18 times 10 equals 2090. And we already decided that we were going to use joules. And that equals Q. All right, give me a thumbs up if that makes sense and you're good with that. All right, that's good. Let's go ahead and look at the second example. Number 2. What is the specific heat of metal if it takes 270 joules to raise the temperature of 100 grams from 30 degrees Celsius to 40 degrees Celsius? All right, so number 2 is asking me what is the specific heat. So I'm going to use the specific heat formula. Q equals mass times specific heat times delta T. And I always write down the variables because it helps me to plug in my numbers in the right places. So go back to my question. What is the specific heat of the metal? Specific heat is my unknown. That's what I don't know. If it takes 270 joules, well, which one of these is measured in joules? Q. To raise the temperature of 100 grams, well, we know grams is mass. So right now we're just kind of looking for our variables. The last one we have is delta T from 30 degrees to 40 degrees. Am I going to use either of those numbers? No. I am going to use the difference. So the difference, the change in temperature, is a positive 10 degrees. So we went from 30 degrees to 40 degrees. So now I can just plug it in. I don't know my specific heat. All right, so first thing we got to do is multiply the numbers that we can multiply. So we'll have 1,000 gram degrees Celsius. And my CP, I didn't do anything with it because it's a variable that I don't know. All right, so now what do I do to find the specific heat? Divide, right? Divide by 1,000 grams degrees Celsius. Divide by 1,000. Make sure we do the same thing on both sides of the equation. So over here on the right, degrees Celsius cancels, grams cancels, 1,000 cancels. I'm left with my specific heat. And you mathematicians can probably just move the decimal place, but I am going to put it in my calculator to make sure I don't make a silly mistake. So 270 divided by 1,000 is 0.27. Now look at my units. My joules per gram degrees Celsius. That is a unit of specific heat. So by checking my units, I can check that my answer is the correct thing. Right? Give me a thumbs up if that makes sense and you're good. Good? Okay. All right. 1033.